problem, what we are trying to do, given accounts, first entry is an account name, the rest is just emails. Combine them, merge these accounts if it belongs to the same person. So in this, how did we figure this out? So John Smith, this email also exists in this email. We can conclude that this John and this John are the same person. What about this John right here? But this John has a different email and it doesn't exist in this list. So that means this is a different John, because like in the world we have so many Johns, but when it comes to email, it's unique. So that's how we figured this out. It's the same person and we combined them together. So, and then when we combine this, it's also asking we should do it in sorted order for these emails. Since there is a connection going on, we can represent this one in graph, and since we can represent in graph, we can do the traversal of it. We can do some type of like DFS, and then from there, like visit all those emails, and then once, and then construct our list. But in this problem, I want to actually solve it with union find pattern. Union find I have already defined in here. I covered this pattern in previous videos, so just a quick overview. It has two methods, find and union. Basically for different, we assign a representative, its parent, and then that's how we can find the representative, the parent of it, and then union for given two different sets. We are just like combining them together basically, and then updating the parent of it. So this is a quick overview. Now let's implement this in our problem in here. So union find, first thing first, let's create the object of it, union find, and then we'll just give the accounts size of it. So in first entry we have 4 in here, so 1, 2, 3, 4, and that's what we gave in here. And then first thing first, so let's actually create the map where we have a key as an email and value as in its ID. So if we see this email again, then we will just call our union find and just like combine them together. So let's go and create our map. So the key is our email, value is the integer of it. So email group new hash map, and we'll go over this accounts list, and then let's just create our loops in here. So row is starting from here, I smaller than accounts size I plus plus, and our column is so first one is account name, so we'll just skip this and start from 1. So j smaller than accounts get I of size of it. So perfect. Now we are able to see each email in our account. So let's say string email, it will be accounts get I and get j. So this is each email in there. Now we're going to ask if we have not seen this email in our emails group, then assign it. So email group, put this email and give its ID. So else, if we have seen this one before, then we can just like call our union method. So pass our ID that we're currently seeing it, and also the previously we have ID we have assigned for this email. Perfect. So this is complete. We have constructed our email group map. Next thing is now, since we have this one, we need to construct our parent representative ID along with all those emails. So for that, we also need a map, and representative is an integer, and list of all those strings will be our email. So email components, new hash map. Perfect. So for we can say for each of this entry in our email group map, which is string and integer entry in email group entry set. And what are we going to do? We are going to find its representative. So int representative. So we'll be calling our find method in here. So for given entries, get. So representative is, we can see, because like we were saving all those IDs, and in here we can just like get the key of it, and it will give us the representative. Now for each representative, we need to save it in our emails component list. So compute if absent for given representative. If it's empty, then just, if it doesn't exist, then new array list, and we'll just need to add entries and get key, because key is an email. So now we have a map where we have integer as a representative and a list of all those things. Now final step left, where we just need to construct our merged list basically. So list of string, so merged accounts, new array list. So this will have the final answer in there. So for now, so in this one we constructed the first step, all this email to its ID. Now this is representative to all these emails. Now we'll be using this email components. So map entry, it has integer and all those emails. So entry in email components entry set. Perfect. From here we need to sort it as well. So from here we can say list of this string component. So component exists in get value of the components, email components. So this is the one we are seeing right now. Then we can call the collections sort method in here. So we'll pass in component. Perfect. So this sorted. Now the next thing we need to do it for component. We need to assign, because like here where, as you remember, it's like we have skipped the account name. Now we need to bring it back, because now we only have all this emails just like this. Now we need to insert this thing, account name component, add. So in the first index we will just add accounts get. So entry get key contains the representative. So in here, it's like, let's say it's like we were able to see this list. Now we need to get the first entry of it. So get in here. Where was I? There we go. 0. So this is the first name of it. So that's how we add it in here. The final thing we just needed to just like collect all those components in our merged accounts. So component, and then in the end just return our merged accounts. Perfect. Let's run our code. Entry get key. Where is it? 58. Oh, what happened here? Get key. Oh, so email group string. This is not a, yeah, this is a value, because like we need to get the value. This is a key. Okay, perfect. So let's run it. So get value, it's an in here it's an integer. That's what I wanted to get. So let's submit it. Perfect. So what is the time complexity in here? So let's calculate the time complexity. So we can say that for we have an account and uh, we have the list of those emails. So in order to see everything in here, so we traverse it. So we can say O n times k, where n is all this accounts in there, and then k is its corresponding emails. And on top of that, what else do we have in here? We are also using this collections dot sort, and collections dot sort in Java, it utilizes a quick sort, and it is O n log n. So we can say, and then also some other components in here where we have this uh, find and union. So these are amortized n, which is really close to constant, but it's not. So we can just like overall time complexity, we can just like disregard that constant because like it will be very small. So overall, we can say that this is O n times k log n. So and then space complexity, we are using hash maps in here, all those maps, and to save it in our list in here. So we can say O n times k.